Okay, so previously we talked about cardiomyocytes and autorhythmic cells. So now we're going to talk a little bit about the time when each of the different channels opens and closes for these specific action potentials. So first we'll start a little bit with the cardiomyocyte. So we have something known as IK1, and this is opened at the beginning here during stage 4, during stage 3, and during stage 4 here again. So it's opened pretty frequently, but nowhere in between the center part while it's depolarized. It's only during the hyperpolarized and the repolarization that it turns on. And so those are the moments there. While here we have INA. So the INA or I-sodium channel is opened right at the end of section 0. For a brief section, at the end of section 4, going into section 0, and it just bursts up very quickly, so it's very brief. Unlike that, and right after that happens, I-toe, it opens, or the I-transient opens for a little bit of time to start the repolarization, leading the I-cal-L type or long-lasting to open for a little bit more, for around this whole section here, this whole section, while the IUR is very short section, only for its little bit. Same for the I-rapid, and the I-slow is open for a little bit more, but not very much, leading into the IK1, and that is how long these are all open. But even during all this, there's a channel known as IK ATP that's open during this whole phase without stopping, and it provides us with the ATP needed to continue going. So now moving on for the cardiomyocytes to the autorhythmic cells. Here we also have IK, but IK here isn't open for as long. It's only opened during these moments of repolarization, so it'd be like around these parts right here. Instead, we start with the hyperpolarized channel here, and with the I-acetylcholine, and these are open during the parts that is most hyperpolarized, and it actually causes the cell itself to be more hyperpolarized.
Okay, can you take HCN channel? When the line goes below the threshold,
yes,
HCN open, but all these sections.
Yeah, so these sections when it dips down the channel, that is when it's open. While it's before it reaches the RPM necessary, those are the moments that the HCN and the I-acetylcholine are open. So these whole sections right here, and they get turned off the second that it passes the threshold. Unlike that, here we have I-calcium transient, and these are open for brief seconds the moment that the cell reaches the threshold, and it quickly depolarizes the cell and closes very quickly, allowing its longer lasting part, the I-cal-L, to open for a little longer for this whole peak area. And after the I-cal-L is open, that is when the IK comes in. And then again, the IK will close once it gets down to the hyperpolarization moment. And before that happens, when the threshold is brought under, again we have the HCN open here and the I-acetylcholine. And during this, we also have the IK ATP open again for everything except for the very moments that is most hyperpolarized.
Yes. Today during the lecture, Brother Shell mentioned about that if I add beta-1 receptor in the heart, what would happen to the autorhythmic cell? Will be more like less steep or more steep?
They're going to be more steep because the beta the beta-1 are going to release adenyl cyclase, which will allow this to be open more, and so this is going to be more steep. So if we get a different color,
Increase camp.
It's gonna
Yeah.
increase the camp, which is gonna make it go
Mm-hmm.
steeper
Yes.
and faster.
Mm-hmm. What about we open more HCM channel?
More of these.
Mm-hmm.
If
More
we open-
HCM, more funny channel. We increase the
Yeah,
amount
okay.
of a funny channel.
So if we increase the amount of the funny channels, it's going to cause the dips here to be
Mhm.
more drastic, and it's
Mhm.
gonna lengthen it a little bit more because it's
Mhm.
gonna take more time for it to depolarize, and then
That means more
Polarize.
steep or less
it's
steep.
gonna be less steep. So opening these up, they're
Mhm.
gonna be taking more time, and then it's gonna go deeper, and then take longer times, and the peaks aren't going to be as big.
Mhm.
And so that's kind of how the green is going to be how it looks like. Is that these funny shells are open more, while the orange ones are gonna be when we add beta 1 into the cell.
If we stimulate the muscarinic receptor, then what would happen? M receptor.
The M receptor.
Like M receptor is from exam 1. It kind of relax. It kind of decrease its activation.
Yeah.
Yeah, so and muscarinic receptor is IP3, like a muscarinic 2 and 4 decrease the camp. And
Okay.
what would happen? Which one would the case?
So if we do that, we're gonna have an increased amount of IP3, which is going to allow the cell to be depolarized for longer. So they're gonna be less steep. It's going to be longer again.
Yes.
Just like the green ones.
Yeah, muscarinic 2 receptor especially it decreases the camp. So
Yeah.
it means the will be less steeper or more steeper.
Less steep. Because
Yes.
as we saw when we added more camp
Mm-hmm.
with the adenyl cyclase,
Yes.
we ended up with steeper peaks
Mm-hmm.
with the orange. But since we're decreasing the camp, it's going to do the opposite. They're gonna be wider peaks, less steep.
Okay. Can we find the voltage gated sodium channel in
Yes.
autorhythmic cell?
Autorhythmic cell?
No. And where can you find it?
You can find a voltage gated stimulated channel.
Sodium channels.
Sodium channel here in the cardiac, in the cardiomyocyte, and it's the very first thing.
Yes.
It is the main transition point of the cardiomyocyte, while the autorhythmic, instead of using that voltage gated sodium, it uses these funny cells.
Okay. Funny channel will be activated by this one. What is this? Funny channel opened by this.
Funny channels opened by. Is it ligands? No.
CAMP.
They're opened by CAMP, by CAMP. Okay,
Yes.
this makes sense because when you increase the CAMP,
Yes.
that's when they get steeper, and because they're opened for longer.
Yes. So how can we activate it? That means how can we activate it, increase the camp then? How can we increase the camp? You say increase the camp, and then how can we increase the camp?
You can increase the camp by adding beta 1 or
Beta 1 receptor can be activated by which neurotransmitter? So
glutamate.
okay, beta 1 is the adrenergic receptor, right?
Yeah, is it I know that there's a beta receptors that release camp. I know how it works after, but where are they activated by? Is it glutamate?
It's acetylcholine.
Acetylcholine. Okay, that makes sense. So you have acetylcholine here.
Yes.
So adding beta 1 receptors and adding acetylcholine allows us to have an increase of camp, which allows us to have a steeper play.
Yes. Okay. Do you have anything?
No, but these are the main differences. Thank you.